So where are we heading with all this trigonometry and all these definitions? Well, one of the big places that we're heading is a procedure to solve right triangles, given two pieces of information. Two pieces of information. So, what we're going to do is we're going to sketch a right triangle and label the sides and angles. Let's go ahead and do it for this problem. I'll come back to this procedure here in a minute. So look at this right triangle that I've drawn for you, and it could be drawn in any way, shape, or form. I didn't have to put the right angle over here in the lower left corner, but I just did. So I'm going to call that angle C, and therefore the side opposite will be little c. I was given in this problem angle A is equal to 18.4 degrees. And between this angle and this angle, which one looks a little bit more like an 18-degree angle? It's this one, isn't it? So angle A is equal to 18.4 degrees. So I'm trying to draw this picture to scale. Since I know this is angle A, then I would come over here and call this angle B, capital letter B, and of course I'd call this side B. Remember, if this is angle A, I'd call this side A. So our first step is to sketch a right triangle and label the sides. I've written here, circle those parts so you have information on the triangle. So you see right here, side C is equal to 3.72. If I'm asking you to solve a triangle, I have to give you three pieces of information. So here's angle A at 18.4, and here's side C at 3.72. The one other piece of information I gave you is that this is a right triangle. So angle C is equal to 90 degrees. You see this box over here? I'm going to suggest that you use a box like this every time you solve any triangle. And in this box, you put 3 capital letters and 3 lowercase letters that are those sides opposite an angle. So if this is the right angle C, then this is side C. And fill in the information that you know. So I have a 90-degree angle in this problem. I have an 18.4 degree angle for angle A, and I have side C is 3.72. There are two situations in terms of solving right triangles. One is that I give you an angle and a side, which is this situation, and the other situation is that I give you two sides, the length of two sides of the right triangle. That's the only possibilities. I always give you this, and then I can either give you one of these two and one of these, or I could give you two of these. This particular problem, of course, is going to focus on this first situation where I give you an angle and a side in a right triangle. I would like to remind you that the sine of an angle is the side opposite over the hypotenuse, and the cosine of an angle is the side adjacent over the hypotenuse, and the tangent of an angle is the side opposite over the side adjacent. So always remember that. Don't remember in terms of A's, B's, and C's. But what I'd like to do now is I'd like to refer to the angle that was given me, angle A. And as a matter of fact, I'm even going to highlight it. I'm going to highlight its value. I'd like to remember that I was given side C and that the value of that is 3.72. And now what I'd like to do is I'd like to write these three definitions again, all over again, but instead of using the letter theta, I'm going to use angle A. So I'm going to come over here. So again, it says here next, express each of the three unknown parts in terms of the known parts and solve for the unknown, and then we're going to check our results. So I'm getting ready to express the unknown parts in terms of the knowns. But remember, the known is angle A. So I'm going to write the three definitions. The sine of angle A is equal to the side opposite it over the hypotenuse. So again, here's angle A. This is the side opposite it over the hypotenuse, A over C. The cosine of angle A, right here, is its side adjacent, which is side B, over the hypotenuse, C. So it's B over C. And the tangent of angle A, remember tangent is defined as the side opposite over adjacent. So the tangent of angle A is this side opposite over this side adjacent, A over B. I'm developing this so that I can get ready to solve for these sides, but I'm afraid I forgot to go for the easy thing right away. I forgot to go for angle B. If I know angle A is 18.4 degrees and I'm in a right triangle, then angle B would be equal to 90 degrees minus that acute angle of 18.4 degrees, and therefore 71.6 degrees. And I'm going to fill this in. I like to fill that in as calculated information, so I've used a different color. Angle B is 71.6 degrees because I'm always going to try to be using the given pieces of information in solving for these other two pieces. Now, I'm ready to go back over here and decide, in order to find side A and find side B, I just have to use two of these three equations to do that. So what I'm going to ask now again is to remember you were given angle A and side C. So see this angle A? I was given angle A, and I was given side C. See this right there? I was given side C. I was given side C. There is no C over here. So if I would use this trig function and fill in the number for angle A and for side C, I would be allowed to solve for side A. And I'd fill that answer in here using algebra. If I would use this equation and fill in the 18 degrees-ish for angle A and side C of 3.72, I would be able to solve for side B because it's the only thing I don't know in this problem. I'd be able to put that answer right here. But see this trig function tangent? It requires the use of A and B. And I don't know either of those. So in algebra here, I cannot solve for two letters unless they have two equations to do that. So I'm not going to use that statement. I'm now going to turn to this statement, and I'm going to put in numbers. So angle A is 18.4 degrees. So for angle A, I'm putting that in. I do not know side A, but side C is 3.72. I just now need to get this side A all alone. And so what I'm going to do is I'm going to multiply both sides by 3.72 so that I can cross off this denominator here with this, and A is all alone. A is all alone, and it is found by, would you take your calculator and type 3.72 times the sine of, it will open parentheses, 18.4, your calculator's in the degree mode, close the parentheses, and then hit enter. And I believe for side A, you should get 1.17. I'm going to go ahead and fill that in right here. Fill in my answer. Very good. So now I've got to find side B. Yeah, you know, this is a right triangle. So side B could be found using the Pythagorean Theorem, but I'm not going to do that. I'm going to go use this statement right here to find side B. I'm going to fill in angle A and side C into the cosine statement. I'm going to have to write it way down here. So that is that the cosine of angle A is equal to side B over side C. I would like to show you a different way algebraically to think about this. Yes, you could multiply both sides by 3.72, but don't forget proportions and cross products. If you put a 1 underneath this, you could set this cross product right here, 1 times b, which is b, equal to this cross product right here, which is 3.72 times the cosine of 18.4 degrees, and that's what you need to type in your calculator. So I actually type in 3.72 times, so hit your times key, cosine, it'll open parentheses, close parentheses, I'm going to make that a little bit bigger, close parentheses, hit enter, and you should get that side B is equal to 3.53. I'm going to go ahead and fill that in right here. Here's where the Pythagorean Theorem comes in now. What I'd love for you to do is I'd love for you to check your answer over here by taking A and B and putting it into your program, or hand typing if you will. So take the square root of 1.17 squared plus 3.53 squared and hit enter. Again, or use a Pythagorean Theorem program, and it should give you an answer of 3.72. If these two sides in the Pythagorean Theorem give you this, then you know you've done this problem correctly based on this angle. The next two problems are just like this problem. So I'd like you to go ahead and work on the next two problems, and our next our next video will show you the answers. So I'll do it relatively quickly. So work on the next problem number 2 and number 3 on the next page, and we'll come back at you.